Hello everyone. Today I want to speak to you about how we might calculate average speed of objects, of people, of vehicles, of anything that's moving essentially, and what the maths is behind that. So maybe if you thought about some of the units that we use to measure speed, or when we talk about speed, you might be thinking about units such as miles per hour. You might have kilometers per hour, perhaps when we're talking about cars and things like that. We might talk about things such as centimeters per second, maybe millimeters per second. Lots of different units can describe how things might be moving. But importantly, it's worth considering what these units are made up of. What we call these units are compound units. That's because they're made up of two different measurements. Let's just take, for instance, miles per hour. If you say that back to yourself, you can work out that there are two individual units there. There's a unit of distance, where we have miles, and there's a unit of time, hours. So we've got miles per hour. Similarly, with this one, we have kilometers, our distance unit, and we have the time unit of hours again. And likewise with centimeters, distance, seconds is time, millimeters is distance, and seconds is of course a unit of time. So we use compound units to describe speed. So if we thought about what's going on there, we've got a relationship that we could calculate as speed must be calculated with something to do with the distance that you've travelled and the time that you've taken to do that. And like I said before, this could be in hours or seconds, and the distance could be in miles or kilometers or any distance measurement, and the times might be in seconds or hours or maybe minutes. Lots of different time units that you can use. Importantly, the main thing to remember is that when we calculate these average speeds, calculate the numbers behind them, what we're relying on is this relationship that speed can be calculated by taking your distance that you're travelling and dividing it by the time that you've taken to complete that distance. Now, importantly, what we're going to do today is calculate what's called average speed. So that's the speed that you take over an average time, and not taking into account that you might speed up or slow down within your journey, or maybe even stop within your journey. So let's just do an example to start off with. Let's imagine that I went 100 meters, that would be my distance, and it took me 10 seconds to travel that distance. Well, just ignoring the units to start off with, I know that 100 divided by 10 would be 10 meters per second. So by dividing within this relationship, we actually create our compound unit of 10 meters for every second. So if I imagine I was walking at this average speed and I walked for 10 seconds, I would end up covering 100 meters. Let's think about a different example. I'm going to change the units a little bit. Let's imagine that I went 50 miles and that took me 2 hours. Well, I could say that that's going to take me 50 divided by 2, that's going to take me 25. And now let's think about my compound unit. Well, I've got miles divided by hours, so it's going to become miles per hour. And let's think about that, what that actually means. That's telling me I cover 25 miles every hour. So if I imagine within my first hour, I'm going to be covering 25 miles. And in my second hour, I'm still going to be moving at that same speed. I'll cover another 25 miles. And that would take me up to 2 hours of travelling. So overall, I've covered 25 plus 25. I've covered my 50 miles in that time period. Okay, here's something to think about. I'm going to bring in a bit of a demonstration. I'm going to introduce my fit cyclist called Eddie. He's very fast. We're going to nickname him Steady Eddy because he travels at a steady speed. He's very good at doing that. Today he's going to go along this route that I've mapped out here. And the route as it stands, the route that he's going to go on first, is going to be 30 kilometres in length. So he's going to cycle an average speed. He's going to try and stay constant. He's going to try and not speed up and slow down. And he goes along this route, 30 kilometres, getting to the finish, and that takes him 3 hours. So he gets to the end and he wants to think about, well, what was my average speed for that journey? So remember that we had this idea that we could calculate speed as distance divided by your time. Remember that the distance was 30 kilometres and his time was 3 hours. So I know that 30 divided by 3 will give me 10, and my compound unit would be kilometres divided by hours. So my unit of speed this time is going to be kilometres per hour. That's telling me for every hour he would be covering 10 kilometres. Now that's saying that he's travelling at an average speed. He might have slowed down, he might have sped up, depending on hills and things like that, but it's telling me that on average, for every hour, he's covering 10 kilometres. Okay, let's have a look at something a bit different. He goes out again the next day, but this time he decides to take a bit more of a scenic route. And the route that he takes us round this bend here, back onto the original road and to the finish. But this time, it adds on 10 kilometres to his route. And it is a little bit more hilly, this bit here. So it actually takes him 5 hours altogether to cover this new route, including the hilly loop back onto here. So I want you to calculate, does he move at a quicker or slower average speed? Pause the video and see if you can work it out. Okay, so let's plug it in to our division here. Remember that it's speed divided by time. Speed will be your distance divided by your time. Let's take our numbers that we've got. Well, we've still got our distance in kilometres. Remember now that it's 40 kilometres. And this time he took 5 hours to cover those 40 kilometres. Let's think about 40 divided by 5. How many 5s are in 40? Well, that's going to give me 8. And then it's kilometres divided by hours. So my unit of speed still stays the same, kilometres per hour. So now I can see and compare my two speeds that I've got 10 kilometres per hour versus 8 kilometres per hour. So what I can say on average is that in his second journey, he was travelling 2 kilometres slower than he was in his original journey. So that hilly extra 10 kilometres really ate into his average speed there. Here's a little task that you can do, and I'll put the link in the bottom of the video. It takes you to a site called Go Teach Maths where you can download this sheet and have a go at it yourself. Alternatively, if you want to pause the screen and have a go at it with it on the screen as best you can, then please do so. All it is a true or false maze. So you're starting on this side of the maze and you're faced with 4 options which might be true or false statements. Depending on what they are, means that you can progress through them and hopefully linking together boxes which get you to this side of the maze on the finish side. So I'll just do a couple to start you off, and then I'll leave it up to you as to how you carry on. So let's have a look at one of those statements on the top level. For instance, let's have a look at this top one here. What you're presented with are 3 pieces of information. It's telling you an average speed of 20 kilometers per hour, and you have a time of 2 hours, and you have a distance of 20 kilometers. What it's asking you is this a true or a false statement? Is this speed calculated but by dividing this distance by this time? Remember, let's think about our relationship. Speed equals distance divided by time. Well, let's plug it in. My distance is 20 kilometers. My time is 2 hours. 20 divided by 2 is 10. And I had kilometers divided by hours. Well, that would be kilometers per hour. But I can see that my average speed, if I did a journey of 20 kilometers in 2 hours, my average speed would be 10 kilometers for every hour. So that doesn't give me an average speed of 20 kilometers per hour. So we're going to have to say that this statement here must be false. So in terms of my maze, my starting square can't be this square. Let's just have a look at this one to get us thinking again, and then I'll let you go at your own pace. So our information is we have a time of 3 hours. I'm going to input it into our relationship here. Remember, speed is distance divided by time. Well, our time is 3 hours, so that goes on the bottom, 3 hours. Our distance, what is it? 35 kilometers. Let's do that division. 35 divided by 3. How many 3s are in 35? Might have to get a calculator at this point, or maybe do a bus stop division. So let's just do a quick bus stop. 3s into 3 go once. 3s into 5 go 1, remainder 2. And it would be 1 remainder 2 out of 3. So I know that and if I converted this to a decimal, I know that this would be 0.666 recurring. So I know that this would be 11.6 recurring kilometers per hour. And am I looking for an average speed of 5 kilometers per hour? Well, no, that wouldn't work. That's too low. What I've actually calculated is if I covered a distance of 35 kilometers in 3 hours, I would have to be moving at an average speed of 11.66666 recurring kilometers per hour. So this must also be a false statement. I'll leave it up to you to decide, is this square here or this square here a true or false statement? Then you can progress on to the next level and think about what direction you could go following along and trying to get to the other side.